Chapter 3, Complex Numbers. Today we are going to talk about De Moivre's theorem. De Moivre's theorem states that a complex number in its modulus argument form, when raised to the power n, gives the results as shown on the top right hand corner, where the modulus is raised to power n, and its argument, which is the angle, is multiplied by n. We can apply De Moivre's theorem to proving trigo identities. Here I provide some steps to guide you along. You may also find it useful to be familiar with the binomial expansion. Example 13. Use De Moivre's theorem to prove sine 3 theta equals to 3 sine theta minus 4 sine cubed theta. In the orange box on the left are the 5 steps we should apply. Number 1, choose n. Number 2, expand using De Moivre's. Number 3, expand using binomial. Number 4, compare the real part of the imaginary part in steps 2 and 3. Number 5, conclude the question. Here I provide a reminder of the De Moivre's theorem in modulus argument form. In such question, it is a practice to let r equals to 1. So we will be applying the expansion cos theta plus I sine theta to the power n. Take a look at the question again. Compare the left-hand side, sine 3 theta, and pay attention to the pink box. Now take a look at the blue box on the bottom left. Again, pay attention to the pink boxes. In this case, it should be quite clear that we should choose n equals to 3. By De Moivre's theorem, when we expand cos theta plus I sine theta raised to the power 3, we would get cos 3 theta plus I sine 3 theta. Then we should expand the same expression using binomial theorem. The formula for binomial theorem is given in the purple box. You should get what is shown on the screen now. An elaboration of the expansion in green is provided on the left. Be reminded that I squared is negative 1. Thus, the final outcome should give negative 3 cosine theta sine squared theta. Similarly, the expansion for the term in the red box is shown on the left. I cubed is minus I, so the final outcome is minus I sine cubed theta. This is what we have so far. Let us look at the question again. We are supposed to prove for sine 3 theta. Let's look for it. In the De Moivre's theorem expansion, we find that the sine 3 theta is exactly the imaginary part. Since we are expanding cos theta plus I sine theta to the power 3 in 2 different ways, we can compare their imaginary parts. We write, like in the bottom, comparing imaginary parts, sine 3 theta equals to 3 cos squared theta sine theta minus sine cubed theta. Now let us look at the question again, this time paying attention to the right-hand side. Notice that the equation we have written previously, that I have moved to the top of the page, contains cosine squared, which is not what we want in the question. So we should use an identity, 1 minus sine squared, to replace it. Next, we expand and then simplify the like terms. We should get 3 sine theta minus 4 sine cubed theta, which is equals to the right-hand side. Hence, we have concluded our proof. A full solution to this question should look like this.